everybody, and welcome to our breakout session. Today, we're going to talk about what's new and what's next in TIBCO Streaming. My name is Monica Cisneros, and I'm Product Marketing Manager for TIBCO Streaming Analytics portfolio.
And my name is Manish Patel. I am a product manager for TIBCO Streaming Analytics portfolio.
Hello, I'm Thomas Hill. I'm the Senior Director for Analytics and the Product Manager for the Data Science products.
First and foremost, a disclaimer. Today, we'll be making some forward-looking statements which are subject to change, so do take note of that. As most of you are familiar with TIBCO's portfolio, TIBCO's mission is to solve your end-to-end data problems. Our goal is to help you connect to that data, unify that data, and then put that data into action with our Predict Analytics portfolio. This session is focused on the Predict pillar, and we'll be talking about streaming analytics in specific. Key takeaways will be talking about three big items, which are dynamic learning, cloud, TIBCO cloud data streams, and TIBCO model ops that is in our roadmap. What we want you to take away is what is the reason behind all these features and new products, what is the value, and what problems they can solve for you. Let's start with Dr. Tom Hill.
The next things I wanted to talk to you about is a new feature that we think will be extremely useful and in the streaming context for streaming data. We call it dynamic learning from real-time data. So here's some considerations. What happens when an important outcome, KPI, event, forecast, must be made without really any specific precedence in the data that would reflect on what is likely to happen? So when events have no precedence, when they're brand new. What happens when today's business practices and methods are no longer relevant for what we need to be doing next? Something we observe really right now in many industries that have been disrupted. Or what happens when you need to make a very, very fast decision and simply don't have time to go through a regular data science and machine learning type cycle? So the question then is, in your data and your application, are the patterns always the same so that we can mine the historical data, build the models, and then use those models to inform our decisions? Is there enough time to complete a data science project? Sometimes they can require a lot of time, that can be quite lengthy, require multiple teams. Does success in your industry, in your application, your organization depend on being the first? So to act very quickly when new situations emerge. And perhaps there isn't any real historical data that's relevant at all. If a new machine is being commissioned, there may not be any data. So the requirements here are, why not analyze data as they are collected? Can we not deliver insight in real time as the data stream in? Now, to summarize and distinguish and differentiate between these approaches, consider the traditional data science approach. There we look at historical data, we extract them, we understand them, we prepare them, we wrangle them, we create models, evaluate models. We go through the cycle several times. We deploy the model, monitor the model, and update if and when necessary. In contrast, the dynamic learning approach means that we're putting the learning algorithm directly into the streaming data. And therefore, we can update, adapt to new information, and surface the most recent insights directly through our BI platform into our automation system, and of course with Spotfire, and I'll show you a few examples of that. So fundamentally, the requirements are, we want to be ready to give an answer, make predictions about clusters and patterns at any point in time as data stream by. And we want to be able to adapt to temporal changes in real time. Now, of course, with respect to historical data, we would update models after we monitor them. And we have numerous examples like that from our data science team, how we've done this successfully. But the difference is we want to automate it. We want to do the learning, the adaptation directly in the real-time process. Here's an overview of the type of work that we are doing and the kind of capabilities we want to provide. So we want to provide real-time, so-called incremental learners, mechanisms and algorithms that update models as we move along from the data as they stream by. We want to be able to continuously detect changes, concept drift it's called, when inputs change, relations between and inputs and relations from inputs to predictions change. But we also want to surface statistical analyses and results, because very often when stakeholders, decision makers look at graphs and BI tools, what they really are doing is they test hypotheses to identify patterns, to verify that the patterns are there, their hunches are confirmed and whatnot. And we want to be able to do that more systematically by surfacing statistical results. Of course, we can also connect, always have been, to alerts, automated system and whatnot. And as you will see, it's easy to surface those statistical results and insights directly through Spotfire streaming. So here's an example of a best next action case. Fundamentally, we have 3 buckets of propensity, let's say, since overall, simplified example here. And suppose I have a model, a tree model that puts people into buckets, that is, assigns propensity for specific outcomes to them. Over time, that will change. It always does. And after a few days, after a few weeks, the best propensity model may rather look something like this. If I have a static model, however, I would not adapt. And obviously, if the data, the real data, after a while look like this, then the model that partitions them like that will no longer be accurate. So what you would expect then is for a static model, like the one indicated by the yellow line here, is that accuracy and profit would decrease slowly over time, and probably at some point you would stop it, start the data science cycle to recalibrate and update them on. But in the dynamic learning case, you would expect the accuracy to remain the same because we are continuously updating as the data come by. And even when there's a disruption like here, we should be able to quickly adapt. So in general, the accuracy of static models will decrease over time and requiring an intervention, a rebuild, an explicit rebuild. Dynamic models, however, will adapt. They will remain accurate because they're plugged in directly into the data stream. So from a streaming perspective, we have created a number of new operators, for example, to get the data, align the data, create data matrices so we can apply meaningful statistical algorithms and tests. And in this particular case and use case that I will show you in a moment, we are scoring an actual static model created with one of our data science tools, TIBCO data science tools. And we put the predictions and accuracy and the profits from it directly on a graph and compare it against the dynamic model, which is a dynamically updating classification tree. So this streaming project will drive the visualization, Spotfire data streams in real time, and not only surface accuracy, so the rate of offer acceptance, the accuracy of the model, but also the instant profit. Typically there's profit losses, opportunity losses, so below this line, for each model, the yellow one, the static model, the green one, the dynamic model, but also the cumulative losses and profits, as well as the root causes. So what are the drivers and the changing drivers of accuracy and propensity? And of course, for the static model, they won't change. But as you will see, they will change quite a bit for the dynamic model because preferences change, propensities change. So again, to summarize, we have model accuracy, we have two models, the dynamic learning model, static learning model, accuracy we're tracking. We have instant loss and profit for the interactions as they stream by. And we have cumulative losses and profits for these two models as the data stream by. And finally, we have predictor importance. So explainability, root causes, instant insight, if you will. So here's what it looks like as the data stream through. You can see that both models do rather well at the beginning. Over time, model accuracy deteriorates a little bit, and the dynamic model adapts quickly. You can also see that predictor importance never changes in the static model. We assume the world remains the same. When what you see on the right side here is that the actual drivers of accuracy change all the time. So, in fact, over time, you can see that the static learning model can generate potentially a lot of losses, while the dynamic model, even after a disruption, will very quickly recover automatically, and generate profit, cumulative profit. So, in general, we adapted to concept drift, to the changes on the inputs. We automatically incorporate new dynamics into the prediction. And we avoid any costly data science cycle while maintaining accurate predictions automatically. Now, the second example is for manufacturing, and specifically semiconductor manufacturing. So during the etching process, when we lay down the circuitry onto the wafers, silicon wafers, that happens in the etching process in chambers filled with gases that interact with the silicon and various other chemicals. And we cannot really observe that directly, but it's typically measured by multiple sensors. And you see some of this process here described on the right. So the question is, if I have multiple sensors, multiple chambers, etching chambers, how can I be sure that they're both doing the same thing, that they're equivalent in their quality and their process? How can I determine any root causes of differences if they should emerge? And then how can I very quickly identify and drill down on any yield differences and problems that are attributed and attributable directly to one of the chambers? Again, the general setup is the same. So I'm setting up a streaming project, in this case, one that computes statistics and surfaces them for each one of the etching chambers. I'm not only surfacing the actual data, but also the so-called Kramer's V, a correlation between specific sensors and sensor times and actual product yield, the number of defects on these wafers. So specifically what you see here is the difference in the correlation between machine A and B. And if in fact these correlations are random and are random across both machines, you would expect a random pattern here to emerge. And then of course in the Spotfire display, you have a number of other possibilities to drill down, for example, to look at the actual measurements over time relative to some hard limits. So what we want to do is we want to identify which machine is worse, why is it worse, at what specific sensor time, drill down and validate this insight surface through the statistical analysis. So this is the beginning of this demo. You can see that we have a number of wafers and specific quality indicators, so defects that we find in consecutive wafers. Here again is the streaming project. We're computing chi-squares as well as Kramer's V for 2 machines, and we are streaming those results and the data directly to Spotfire, so we can observe it, surface it, drill down, analyze it, and immediately make decisions if and when problems arise. So this is the process in real time. You see the differences and the correlations between sensor times, measurements, and yield, the difference between the two machines, the two etching chambers, and in fact, the pattern is more or less random. I can sort them into a Pareto chart, which if it's random, will look like a little S-type curve. And so we know everything is in control. There are no patterns, specific patterns in any of the machines or differences. Can also look at the actual observations here and drill down on it. So here are my 6 sensors broken down into 30 sensor times, and then plotted here along the X time axis. Now, as we move along, we look at the differences for correlations. After a while, we see that there is an increase in correlations for one of the machines late in sensor 4, late during the process. We wouldn't expect this hump here. So we can drill down and indeed see that for machine A, the actual measurements get close, but never really quite exceed actual hard limits. While in machine B, we're right in the middle. So we've gone from computing statistics for differences and correlations and directly surfaced them through the streaming data and through the streaming displays in Spotfire to enable drill down and surface actionable information. So we get real-time insights. We surface critical statistical and Six Sigma, Six Sigma indicators, and thereby provide real-time root cause analysis capabilities with these manufacturing data. So we can now anticipate problems in real time as they happen in much more sensitive ways, testing hypotheses, everything happening automatically in real time, directly displayed on the screen. Now, there are many other applications, and I won't spend too much time here. We're working with a number of course, TIBCO is working across various industries. We're working with different customers, everything around financial services, real-time public transportation monitoring, best next action, supply chain, and whatnot. But to summarize, continuous dynamic learning provides insights in real time, putting the learning algorithm directly into the data stream. We therefore do not assume that historical data patterns will repeat and will always be diagnostic of what happens next. Instead, we can adapt and update our models, root cause models, statistical tests in real time, all the time. Therefore, we enable operators to do their data gathering and data preparation, statistical analyses, and machine learning, all of it in a single process in real time, automatically. And of course, predictions, results can drive automated solutions, or can be visualized through Spotfire, which, as you saw, works extremely well. And Spotfire and Spotfire mods are really nicely prepared and set up to host these capabilities and support them. Thank you very much.
Thank you, Dr. Tom. I hope everybody's as excited as I am about learning about dynamic learning. So for the next section, I'm going to present on what is new. So we have 2 major initiatives that we want to highlight in the What's New section. The first is the democratization of streaming analytics, and the second one is closed loop full cycle analytics applications. So let's start with democratization. Streaming is no longer a niche area for developers only. Everybody in the organization, all the stakeholders across different groups, be business analysts, data scientists, domain experts, everybody wants to have access to real-time data. And we want to build streaming applications on top of that. So we need to enable all these different stakeholders, and that is what we call the democratization of streaming. Second, we have closed loop full lifecycle analytics. Customers want solutions for their problems, not necessarily products. And when we're looking at streaming use cases, these problems are more often than not of the closed loop kind. What I mean by closed loop is a whole process of connecting to the data, learning from the data, building models, building insights up top of that data, and then taking those insights and operationalizing them and putting them into action and continuously monitoring the quality of those insights and providing that feedback back into the data scientists. So this whole process of connecting, learning, automating, and acting on data is what we call closed loop analytics applications. And TIBCO has an amazing analytics portfolio to support it. We are committed to have a very tightly integrated, yet loosely coupled experience for our customers using our analytics portfolio. Okay, so let's dig down a little into what we mean about democratization. Before I tell you what's new, let me give you a little bit of history to give you context of where we're coming from, where we are today, and what is new today. In the last few years, we have focused on various different stakeholders. So with TIBCO Streaming 10, we enabled IT, cloud ops, developer persona, with a modern CI/CD tools, out of the box HADR, high ability, and disaster recovery, and scalability. These features that are needed to harden and scale your applications as your use case matures. In 2018 and 2019, we brought streaming visuals and predictive analytics together. What we mean by that is that streaming and visual analytics enable business analysts to really get into the real-time data and leverage real-time dashboards within Spotfire. Then we have the data scientists. We enable them to be able to publish these models by just a click of a button. And the data scientists at the end of the workflow with just a click operationalize those models into streaming applications. So we continue improving in this integration for our business analysts and data scientists. But there is one more stakeholder, one more persona that we'll be focusing on, and that is the citizen developer or the domain expert. Think about your data engineers, your investment trading experts that have amazing business knowledge about the actual use case, but are not necessarily software developers. So we need to enable them to be able to take part of the streaming application process, the streaming application development, and that's when we can see that we are truly democratizing streaming analytics. Okay, so I am super excited and very proud of the streaming team to announce TIBCO Cloud Data Streams. Yet it is yet another step in this democratizing of the streaming initiative, and this is TIBCO's self-serving streaming BI platform. For those of you who are familiar with Spotfire Data Streams product, in the last 1.5 years, the Spotfire plus streaming movement has been growing, and it's amazing to see what kind of problems our customers are solving in this capacity. TIBCO Cloud Data Streams plus Spotfire turns into a unique streaming BI platform because of its self-service capability, and this brings streaming BI to a completely untapped market for non-developers. With streaming BI, we can give power to subject matter experts like dribbling operators, risk operations, trading operations, marketing operations, the ability to look at real-time data into their own hands. So let's address the why first. Technology and business needs have changed, and today's problems demand access to not only after the fact, but they also need access to the now and the future and the ability to query that future. Such instant insights could predict and even prevent processes or production problems before they could actually materialize, and detect a new market opportunity before a competitor sees it and can take advantage of that. The use cases of data streams are endless. Think about the data that you have that changes frequently, like sales leads, transactions, vehicle operations, equipment status, variable devices, social media updates, customer calls, complex manufacturing environments, kiosks, websites, customer orders, messages, supply chain updates. And like I said, the list is endless, and we can just go on and on. Next, think of questions that starts with tell me when, tell me why. And they can be answered in real time, millions of times a day. Streaming BI questions are about the future. Some of these examples would be telling me when a high value customer walks into my store and what most likely she or he is looking for. Tell me when a piece of equipment begins to show signs of failure and should be shut down to avoid costly losses. Another example would be like, tell me when a plane is about to land and I have a high priority passenger aboard at the risk of missing their connection, and what can be done so that, we make sure that she makes that connection. One thing we've always been proud of in the streaming platform is the whole time to market and how quickly we can put ideas into action. How quickly we can test out those ideas and really put them to work. So you can try and create a streaming analytics application with open source coding. With open source custom coding. However, it might take months to implement or even years. With TIBCO Streaming, there's a significant improvement from open source as it takes days or maybe a short amount of weeks depending on the complexity of the project. However, now with TIBCO Cloud data streams, what we're doing is that we're enabling that real-time access to real-time data in minutes. So think of a problem that you need to visualize with real-time data in your BI tool, and in our case is Spotfire. Just like that, we are going to connect to that BI platform, and just the same way that we connect to historical or traditional databases like it is SQL or Oracle. It's that easy. So with a tool with TIBCO Cloud data streams, it allows you to connect to real-time stores like, for example, Kafka and QTT, TIBCO Cloud messaging, again, just in minutes. So I'm going to show you a demo where we connect to Kafka data, and we'll end in a visualization Spotfire all in, just minutes. So here it is. So here's the main page of TIBCO Cloud data streams. You start by picking out your streaming data source, then you provide the address of that data source. The wizard will automatically tell you what topics are running in that bus, and you just simply pick the topic that you want. Then again, it tells you what schema to use, and you choose, after that, you choose the authentication, and boom, your data stream is ready just like that. As I said, in minutes. So the configuration of the data stream is done, and you can start the data stream. Once it's running, you can see the data flowing into the right panel, and we'll jump into Spotfire. So you connect your data stream that you just created and bring your real-time data into Spotfire dashboard, right? Very, very similar to how we do historical data, but also alongside historical data. And we can end in a very powerful visualization such as this one. I'm really excited to see what problems you solve with TIBCO Cloud data streams. And as of now, it has already become GA. And I encourage you to go to cloud.tibco.com and register for a free trial. Also, to learn more, I encourage you also to see my other session where I will show you in more detail how to connect to Kafka data and create a Spotfire dashboard from scratch with real-time data. Okay, so moving on from data streams, next we're going to talk about the admin UI that we recently launched in TIBCO Streaming 10.61. So let me jump into the demo. So the admin UI is a command and control center to manage your deployed streaming applications. It has a hierarchical view from cluster to nodes engines and any specified managed entity. In a way, it is a web interface alternative to EPAdmin command line interface for those who are familiar with that. And some other highlight features of the web admin UI are that you can NQ and DQ streams. You can manage node life cycles, including node install, start, stop, removal. It has some of the security management functionalities, for example, adding users on the fly. Admin UI is a great tool for those who prefer the web interface over command line interface, and it is available in 10.6.1. So go ahead and check it out. So that's what I wanted to show you today under what's new, TIBCO Cloud Data Streams and the admin UI for TIBCO Streaming. And here's Manish to tell you about what's next.
So next on the card is how do we enable this citizen developer or domain expert? We talked about this earlier, right? So let me first give you an example. Imagine you are director of sales for a very popular retail brand, and you're responsible for managing Northeast US region. You want to be able to create a system that monitors all the transactions going through your all the stores in New York branch, right? So as a director of sales, you might not be familiar with your data warehouse, your data lakes. You don't know where your data is, and you specifically real-time data, right? I don't know where it is coming from, and I don't have the expertise to connect to it. So think of a platform that allows you to be able to see, okay, here are my New York transaction data. Okay, I want to drag that. I want to filter on that data. I want to aggregate that data for whatever time period. And here is the alert I want to set. Here is probably I want to send myself an email when something like this happens. So this new platform is going to be completely drag and drop, no code. It's going to be modular and collaborative. What I mean by that is you, as a business user, you are working with your engineering team, and they help you create these blocks so that you can consume it, right? And it will have industry and application specific blocks. The advantage of enabling this business user persona is you can innovate much faster. Imagine leveraging the expertise of this business knowledge and making your whole development much faster, right? So you're boosting innovation. We are really excited for this specific initiative, and we look forward to sharing more details when possible. So stay tuned. With that, let's move on to our next initiative that we are focusing on: closed loop full lifecycle analytics applications. What are they, right? So let me explain you what do we mean by closed loop applications with TIBCO's analytics portfolio. You connect to your real-time data coming from various sources: IoT data, messaging, databases, fix, social media. You bring that data into TIBCO Streaming. So ingestion is done. Now you transform this data into whatever form your use case demands. So you clean, you aggregate, you filter, you enrich, you add contextual information, right? So now you have the data that you need. Once you have the data that you need, you either send it to data streams to be visualized in real time, or you might send it to a persistent store. Next step is you visualize that real-time and historical data in Spotfire. And the beauty of Spotfire is you do that in one dashboard. You have your real-time data and historical data side by side. You learn from your historical data. You create insight on top of it. You create models in your TIBCO data science platform. Once you have those models, you put those models into action. You operationalize those models into your streaming applications. And now, once you have the historical intelligence in your TIBCO Streaming, you take advantage of that in real time. And with that, you automate your decisions and take automated actions based on that. Also, while doing that in TIBCO Streaming, it keeps an eye on the quality of the model and constantly provides that feedback back to the data science team as the quality of that model degrades, and the data science team takes that into account, updates the model, and they can hot deploy the updated model back into TIBCO Streaming. Our new initiative in extending this closed loop is what we call model ops. To get more details about model ops, I encourage you to go ahead and check out our what's new and what's next session for our TIBCO data science. But a couple of things that I'd like to highlight here is TIBCO model ops is source and destination agnostic. So not just TIBCO. TIBCO tools, your models can be coming from anywhere, any data science tools, and can be going anywhere, including but not limited to TIBCO Streaming. And it also supports various models of deployment, spinning up a callable running server, deploying a model directly into a TIBCO Streaming application or any custom applications, right? So as I said, I really encourage you to go ahead and check out our data science, what's new and what's next session to learn more about model ops. Last but not the least, connectivity. This is pretty much static on our roadmap, all our roadmaps. We boast about having one of the largest connectivity portfolio. We connect to over 90 different real-time technologies. And we also understand that the connectivity part of streaming space is very dynamic and changes very rapidly. And so our platform has been designed in such a way that not only for our developers, adding a new connectivity is much, much easier. We made it extensible so that our developers, our partners, our customers, everybody can build connectivity much, much, much faster. I'd also like to highlight our integration with our predictive operators. That is, you can do inline scoring for TER, R, PMML, H2O, Python, TensorFlow, and so on, right? And I'd also like to highlight some of the recent addition into our portfolio. That is OPC UA, TensorFlow, Slack, SMPP for messaging, ETP for it's the protocol for oil and gas, JMX, and yes, before I forget, I'd also like to highlight the fact that TIBCO now also includes commercial support for Apache Kafka. Okay, that's that. So back to key takeaways. Just a quick recap. We wanted to highlight the new dynamic learning capability in TIBCO Streaming, the new product TIBCO Cloud Data Streams that enables real-time data and dashboard in Spotfire, and in minutes. You connect to your real-time data source and visualize in Spotfire in minutes. So the experience is just like connecting to any historical data. And last but not the least, model ops is solution for all your operationalizing model problems. So with that, we really look forward to working with you on this new products, new features, and see what exciting problems we can solve for you. So with that, signing off. Thank you so much.